Hello, ladies and gentlemen, boys and girls. My name is Dr. Min, and I'm your tutor for this 8-way movement tutorial for 3D models. We are going to go through that rather quick. I would say it's not a bit, yeah, not too much. Probably I'm gonna implement some animation stuff as well, since I have two animations like an idle and an walk, and we maybe go into that as well. Meanwhile, doing so. But beforehand, I want to talk about the 8-way movement and how we're going to perform that. So at first, what we need to do is, of course, a script which is doing the performance for us directly on our 3D model. You can also use a box or something. I have this little bomber girl over here. So I go and create a new C# script and name that maybe just a movement. And that's probably everything we need to do over here. And we open this one up in Mono, Develop, or Visual Studio as you please and like. And then we go and look into that. I'm gonna zoom in a bit so you can see stuff better once it has been completely loaded. There we go. So I open this one up a bit more. Okay, so what we gonna make use of at first is, of course, not update but fixed update, since we are using the movement based on rigid bodies. So it's going to be a bit slippery, but still it's working pretty nicely. So probably we can just do a bit of strange stuff later on the movement. However, what we want to do at first is we want to say, since we are using a rigid body, we have a required component we want to use or make use of when we are dragging this one onto our 3D model. So first, we type in type of, and then another open close parentheses, we're going to put in rigid body. So this is what we require whenever we want to use this 8-way movement or this movement script. We want to make sure that this is automatically adding a rigid body onto it. Then we have, of course, we need access to this rigid body class or this rigid body component. In this particular case, we name it RB for rigid body. And in start, of course, we're gonna get the connection to the rigid body component. So we say RB is equal to get component, as you already probably know already. And we say rigid body. So we want to get the type of rigid body on start. So we have the connection to it and we can actually work with it and move on it and so on and so forth. So what we need now is we need everything for the input itself. So it's like we need a vertical, a horizontal, and then we can also use raw inputs like vertical raw and horizontal raw. We're gonna start with one and then probably go with the other ones. So we fill these numbers or this floats automatically by it depending on the input we are actually putting in. So I call it float vertical. By the way, you can also put this in a vector or whatever you please and like, but I'm gonna split this up so it's probably easier for you to understand. So horizontal. Once again, we can do the same stuff with raw inputs, like raw horizontal and raw vertical. So I'm gonna maybe rename them to vertical raw and horizontal raw. This is just something you need later on to decide or split away depending on what type of input is coming. So that's how you're gonna make use of the correct input basically. So what we also need is a rotation, because we want to rotate our character in one of these 8 directions we are after. So we say vector 3, we store that in a vector 3, and this is going to be our target rotation. We're going to update all of that later on. Meanwhile, we are actually putting in the data. There's a typo, so target rotation. So once again, this is stored over there, and then we just translate to this. Then we have the rotation speed and a usual speed. The usual speed is going to be like the movement speed, and the other one is the rotation speed, of course. So another 2 floats. Rotation speed. I don't know, we're gonna start rather slow or small, maybe with 10 or something. If we don't, or if you don't like the speed, you can later on go into it and make it faster. You can also use this public or create this public so you can instantly do the changes inside the inspector. I give it a speed of, let's say, 200, because since we are taking time.delta time in consideration with that, well, I believe we're gonna need a rather high number. Also, we are moving everything with rigid bodies, so that there's some like friction involved and all the other stuff. Okay, so instead of using update, we're gonna make use of fixed update, since this is like more or less a physical based movement, I would say, because we are using rigid body and the velocity of or actually the rigid body input and the velocity, of course, yes. So that's why we need to use or make use of a fixed update in this case. I believe there are also a lot of other possibilities that you are not using rigid body for the movement, but maybe something different. Okay, so what we want to do is in fixed update, of course, at first we want to calculate the vertical and the horizontal inputs based on whatever the input is. So, and we are using the already pre-made inputs directly used in Unity. I don't know if they have changed that in the 2K19 version, but I don't think so. So at first we fix in maybe horizontal is going to be equal to, and now we put in the input we are doing. So input dot, and now we want to get an axis. And then here we're gonna type in quotes the name horizontal. Make sure you use a big letter H over here. Horizontal. And you close the line with a semicolon. You can do a copy and paste over there, or you just write everything new, because we need to do the same for the vertical axis. So vertical is going to be equal to input dot get axis. Gonna go up here, close parentheses, in quotes, vertical with a big V, or yeah, with a big V on the beginning. So vertical. Make sure everything is 100% correctly written down, otherwise it might not work or just doesn't really, act as it should. So the next one is we can also do the same stuff with the raw axis or raw axis input. So basically we can copy that. Later on we just need to split this input. So in this case I'm gonna take horizontal raw and vertical raw, just copy and paste them from one place to another. And in here it is not going to be get axis, but of course, as you probably know already, get axis raw. So the raw axis input. There are two different types of axis inputs, so just keep that in mind. They're also both working a bit different in case of what the kind of input we are doing. So now let's create the actual input onto or store them into a vector. So we say vector3 input. So this is the usual input, not the raw input, just the usual input. So in here, we want to create a new vector, 3. And we're going to put in all our inputs based on the horizontal vertical axis. So on X we say horizontal, comma, on Y we don't want to have any Y input because we don't go up, and then we have the vertical. So vertical is going to land in here. And now what we can also do is we can do the same with the raw input. So we can say vector3 input. In this particular case we name it input raw is equal to, and then we create a new vector, close parentheses. In this particular case, once again, we're gonna make use of horizontal raw, comma 0, because once again, no lift up in the y-axis, and horizontal, no, vertical raw, of course, vertical raw. Nope. Oh yes. Okay, so what we now need to do is we need to normalize the complete inputs. So, and how do we do that? We're gonna do some if statements over here. So we say if input, so the usual input that we have created, the first vector, dot square magnitude. So as you can see, it returns a squared length of this particular vector, and is if that is bigger than 1f, so bigger than 1 unit, then we're going to do something. And of course, what we're going to do is we normalize that input. So it's basically getting back to between 0 and 1. So input dot normalize. This one was a big N, open close parentheses, and of course close the line with a semicolon. What we also need to do is the same for the raw input. So for input raw, basically, so if open close parentheses input raw, If that is, of course, the same with the other one, dot square magnitude is bigger than 1f, then of course we want to normalize that once again. So we say input raw dot normalize, open close parentheses, and close the line with a semicolon as usual. Okay, that's pretty much everything for normalizing those. Now what we want to do is we want to take care of the rotation. So what we need to do is we need to request if the input is not a vector 3.0, like the rotational input is not a rotational vector 3.0. So we say if input raw is not equal to vector 3.0, we shouldn't have any like look at rotation problems. Well, I hope. So we just protect that basically. And what we want to have is, of course, we want to say our target rotation is going to be equal to quaternion dot, and now we want to set the look rotation to be, and then open close parentheses, we want to look at the input, so the usual input, and then we say dot Euler angles, so the actual angles based on a vector. Since this is returning vector and target rotation is a vector, we're gonna have to do it like so, like a dot Euler angles. Okay, and what we now can do is we can basically now slurp the rotation like for the rigid body. So we say rb dot slurp. I believe it was slurp. No, it's rb dot rotation, of course. We need to set the rotation of our rigid body onto quaternion dot slurp. So we need a spherical interpolated, rotation in this particular case. Open close parentheses, and inside is where do we start at is going to be transform, or where we start is a transform dot rotation. Then we put in the newly one is going to be a quaternion dot. Since we are using once again a vector, we're gonna go with quaternion Euler. And then we take open close parentheses, and then we take from our target rotation the actual RB rotation. So target rotation dot x. Then we say comma. Then we're gonna round the y movement. So we say mass f dot round, and then in open close parentheses we're gonna put in target rotation y, target rotation dot y, and then we divide that target rotation y by 45. Since we want to have an 8-way movement, we need to take like every 45 degrees, we need to round that and break that down by this. And of course, after we are doing so, let's see if I can make the a bit more visible. I'm gonna say times, and now we're gonna go back and put this onto the actual angle times 45 degrees. So, and the last one is going to be comma target rotation dot z, of course, because the target we actually don't touch them because we are rotating only over the y-axis. So that's where this comes in place. So this is the actual 8-way rotation. And the movement, as you probably already know, is rather straightforward and probably nothing new in here. So basically, we can just create a velocity input or something like that. So based on, once again, the rigid body we are working on. So we can, for example, say we take a vector 3 and we store a velocity inside. So VL, VEL. And we say it's equal to maybe vector 3 dot forward, and then we multiply that by, of course, our speed variable, and we say time dot delta time, for example, time dot delta time, and of course close the line with a semicolon. And what we now need to do is we need to take this vector now and put this into the velocity of our rigid body. So we say rb dot velocity. It doesn't let me. Velocity is going to be equal to VEL, so the vector we have created in here. So this you can always, or this is going to be a good one for you. You have to, or you might be, go into and do some notes or whatever inside that. Yeah, no problem. When you cannot see this one, this video is going to be available on my YouTube channel. So yeah, just watch it later. Thanks by tuning in, anyways. So, and that's basically everything we need. So once again, you can do all your stuff, all your information. You can put them in between the lines and so on and so forth. And that's probably everything we need to do so far. I'm gonna save the script. You probably want to do this as well. And we go back to Unity and see if the compiler has any problems with our code. And once and whenever we are done with that, let's say he has a problem with our no overload for EULA. Let's see if we have forgot a comma or something. I'm gonna have to recheck that pretty quick. Sometimes, typos happen. Oh yeah, of course. We haven't implemented speed and like rotation speed inside of that. So we have like when we are slurping, we gonna well usually I see an info about that. Well, not. Okay. Usually when you're slurping, you're going to take the transformed rotation, then you put in the calculated one over here, the calculated stuff. Then you have the Z value. Oh, more probably I forgot some other input here or there, maybe in the massive dot round. Oh yeah, here's something I missed, I believe. Well, let's see. Oh no, we just forgot, or I just forgot to put a comma in here and say we're gonna put in time.delta time, and we divide, or no, we multiply that by our rotation speed. Rotation speed. I have absolutely no idea if I already created this one. No. Oh yes, I got that here. I'm gonna copy that just in case and see if that is correctly written right now. Maybe this comma is also wrong. Oh, I forgot the parenthesis. Yeah. To close that part. So let's see. This parenthesis is going to be closed here. Then we have one here. No, something is pretty strange over here. So once again, we do a quaternion.slurp. We have this parenthesis is enclosing there already. So somehow I forgot one. Quaternion Euler. So I have two openers. Oh, this one is wrong. Okay, so I'm gonna zoom out a bit so we can probably see this a bit better. So this one, this is the outer one for the very last part. This one here is enclosing the complete quaternion Euler, and this one here is just for rounding the number. So yeah, a bit tricky to get it correct. So let's see if the compiler has any problems. And if it doesn't, well, it still seems to have a problem here anywhere. Still on the RB rotation movement. Oh, probably I forgot to save. Save and go back and let the compiler run and see what's going to happen. And there we go. Okay, so what we now can do is we can put this directly, for example, on our on my Bomber Girl. I can also create an empty like an empty game object and put the movement script directly on it. So I'm not interfering or intersecting anything with the model itself. It depends. Also, of course, on how your rigid bodies are, how your colliders are, and all the other things. So probably I'm gonna just drag this one onto my Bomber Girl. This connection will be lost. That's fine. since we are going to create a new rigid bar or a new stuff for us. So what I want to deactivate is, of course, use gravity, because I mean, yes, there is rigid body involved, but it can happen that this dude is stumbling upon itself when we are using gravity. So we want to avoid that, and don't use any gravity or any other stuff, basically. And when we press play, we should be able to even move around already with keyboard inputs, for example. Oh, it's moving alone. That's funny. Why is that happening? I have no idea, because I guess I'm not doing any inputs. Okay, let's see if we can anyhow fix that with an empty game object. So I create an empty one and zero this one out first, reset, and put all of these things here. I'm gonna give it a little icon so I can see if it is moving around when I press play. Okay, so the game object is also moving at the same time. So probably there's some mistake I have somewhere. I don't know. Let's see. Oh, of course. This one is not a vector3.forward. This one is, of course, the input we are doing. So save that. Because we want to not let it move automatically forward by using vector3.forward, which will automatically add one at a time. We want, of course, to use the actual input for the movement. Otherwise, it doesn't make sense. So now we shouldn't move, except we are moving in like left and right. As you can see, the character rotates automatically. I'm a bit fast. I can also go forward and backward. And if I hit like a top arrow and a right arrow, I'm gonna have this 45-degree angle. You can also check this out over here. And as well as when you're selecting your character, you can see this one is now a 45-degree angle. So you can go like in between those, and you're rounding. Maybe I'm gonna get rid of maximize on play. We are rounding this input like so whenever we are hitting like bottom and left or bottom and right on the keyboard directly, we're gonna have always this. So left is left, right is right, of course up, down. And once again, we can go diagonal when we keep on holding two buttons at the same time. So it is rounded once again to or by whatever the input is, and then it's getting multiplied by the 45 degrees, as we already have written that. Once again, I don't like the speed. It's a bit too fast, so probably I reduce it to maybe 100. I don't know, or even lower. Rotation speed might be a bit too slow. It depends once again on the game you're after or what you're actually creating. So let's see. When we are moving around here, pretty good. So we have this 8-way movement easily set up. So and the rest is this one comes from, I believe, the raw, not the raw input, but the user input. Maybe you want to do the rotation only if that is not vector 3.0. So as we have implemented already, but shouldn't be any problem. Well, at least not for the moment. So, and now we can maybe also connect animations to that. So whenever we are moving in any of these directions or doing actual input, that we say we want to play the walk animation, for example. Or we give it a speed. So when speed is higher than whatever, then we play that. There are so many possibilities to do that. So at first we might want to go and use the animator controller. And since I don't have any, I'm gonna create one pretty quick. So create animator controller. As you can see, this is this one. I name it maybe Bomber Girl, whatever. And I want to put this into the animator controller of Bomber Girl because I haven't created one yet. So whenever I double click that, for example, I'm gonna open up the animator directly for Bomber Girl. And in my 3D models folder, I have this idle and I have this walk. And I can also connect them by doing transitions, right click transitions, and I can give them something as an input. So for example, it will do like, you can check this pretty quick now. At first, it's going to do this idle one. but it is also able to walk once, and it's going to repeat that until we are giving it a condition. So the condition can be like any input you prefer or like. So at the moment, for example, if we don't have any exit time, we want to make sure that we have a condition. Otherwise, Unity is actually not letting us to do any inputs for that. So, and this is going to be like, probably we're gonna take the input directly as an indicator for the animation, or we can make use of an actual speed, or I don't know, what can we give it? We can also just do it by whatever the input is. Like, really, I have no idea. Truly, what can we use? I believe we can just simply use a speed variable. So whenever speed is set to something, we're gonna set a bool or something based on that input. Let me think about that pretty quick. Since I have done that, like, oh, it took a while, or it has been a while already before I did that, or the last time I did that. So maybe gonna take a bool or trigger. Well, no, a trigger doesn't make sense. At least a bool could be pretty much good to go. Maybe we can actually use the square magnitude request over here. So if that is bigger than that, we're going to normalize that and probably are able to use that. Or if the RB velocity is higher than 0, then we can do the walk animation. Let's create a trigger or something, or a bool, or float. Oh, let's take a bool. So maybe that works. I don't know. We're gonna test this. So if bool, we can take the condition and bring this here. If walking is true, of course we do walking, and if walking in this case would be false, we do not do that. What we want to make sure is that these two transitions do not have any exit time, so we can easily and instantly go from walk to idle and back and forth. So, and probably let me debug the velocity over here. So maybe I can say debug.log rb.velocity. So maybe I can do something with it so I can easily trigger, or anyhow trigger the animation better. So now we are at 0, 0, 0 whenever I do an input. So like in this case on an x-axis, I can see that. Like I can see if that x and that or whatever, whichever value is higher than 0, then we can maybe trigger those walk animations by that. So probably that is our choice over here, to use velocity or once again input. Let's see if input is basically also a vector. So I'm not sure. Let's try that. So if a vector 3, no, if val dot x is higher than 0, or is these pipes, or val dot, in this case z is higher than 0, higher, where's the higher sign? Higher 0, then we want to trigger that animation. So we say at first we need to have a connection, of course, to the animator component. So in here we can say animator. I call it anim whatever. And in RB, or in the start over here, I need to get the component of the animator. So anim is equal to get component. That's what we're going to do with the rigid body as well, of type animator. So otherwise we are unable to access it. And the last thing, of course, we want to do is we want to set anim dot, and now we need to have this particular, whatever it is, bool. So we say set bool, open close parentheses, and inside that we can call at first a string name. So we need to put it in quotes, walking. And then we need to give it the trigger true. And what we can also do is we put an else statement. Of course, end the line with a semicolon over here. And we're gonna say else. So if that is not the case, or actually if val x is 0 and basically, so if both are 0, then we want to reset walking. So we could probably just use an else statement, or we can use this one again. Copy. But in this case, we say if x is equal to 0 and, so inside of here, an AND operator, and the z value is 0, then we're gonna set this one here to be false. So we actually deactivate that. So probably that works for our animation. I mean, I only have that 2 animations, so maybe that works. I have no idea. We're gonna see that in just a second. So let the compiler run and see if everything is good to go. And when we are pressing play, we can also go to scene view to see stuff better. So when I go right, whoops, then you can see I'm moving around. Oh, there's one more downside. Since there are also negative numbers, we need to put them in here as well. So 2 pipes again. So if a velocity to that is also like smaller than 0, so a negative number, but actually not equal to, and that's, I believe, the last thing we need to put in. So 3 times an OR operator over here. For the negative numbers as well. So everything is lower than that or higher than that should be able to give us the possibility to set walking to be true and do an instant transition in between those. So let's test it out. So first we should be in the idle state. As you can see, we can look around. And when I do an input to this side, it's actually breaking this one down. Oh, we need to do the animation the animations need to be loopable. So that's what I haven't set up yet. So I need to go to one of my 3D models. I have no idea where these animations are. I believe somewhere here. Here we go. And this one here needs to be set to loop time. So I go to the add walk bomber girl, go to animation and set here loop time and apply the changes. So meaning this is a loopable animation. Same for idle because this is loopable as well. Otherwise she's not unlimited basically idling and stopping after one round of idling around. So as you can see now, my little bomber girl is idling over here. We're gonna get rid of the debug line in just a sec. And when I go right, she is walking to the right. When I go left, she is walking to the left. Same for front, same for backwards, as well as diagonal. And actually that is everything I wanted to cover in this tutorial. I hope you enjoyed this one and I hope you learned something. If you need help with one of your games, feel free to go to octamangames.com. There are you able to hire me for your project or for whatever you like and please. Or if you need a 3D model or anything else, just check out my website and write me a message and I'm gonna help you with your project. So one more thing, or one of the last things I wanted to do is get rid of this little debug line in here. And once again, you can say this is all for the animation. Don't forget to save, and you're good to go with an 8-way movement. Thanks a lot for tuning in, and I hope to see you in one of my next streams or whenever you like and please. Thanks a lot, and bye-bye.